Hello, my name is Cloud Unknowing. I'm a third-year student studying sound production at Box Hill Institute.
And I'm Sophie Rose. I'm a doctoral student at the University of Melbourne. Today we're going to present a paper on the P-Bow, a profane electric violin and bow for use in ambisonic audio environments. This is a design and an evaluation talk. We'll be researching the codification of instruments and the aesthetics of the violins in future research. We were inspired by Laurie Anderson's 1977 version of the tape bow, which she also updated in 1986 to include MIDI. We've been taking a postmodern punk approach to the design of this instrument and using the language of classical instruments to examine expectations is something that we're going to be doing in future research. For this talk, we've created two preliminary works for the P-Bow, Cockwomble. The piece number 1 is by myself, and we'll be demonstrating that one. And Tubular by Cloud Unknowing will be linked to in a YouTube card.
The design of the P-Bow is split into 3 logical parts. Firstly, we have the body of the violin and the associated electronics. Next, we have the bow, which has a wrist-mounted electronics box and a secondary box mounted on the bow itself that contains the gyroscope. The violin body has been brooched in 2 places to provide a set of control buttons near the neck for the right hand and access for an electronic sled to fit inside the body of the violin where it can be flush and out of the road of the performer. The sled itself contains an Arduino Pro, a 6 degrees of freedom sensor, a Bluetooth 2 BlueSMiRF unit for communications, a constant current source for measuring resistance along the nichrome wire that forms the controller, and an interface board for the buttons at the neck. The neck itself has been modified with the addition of a solid aluminium plate that conforms to the curve of the fingerboard. The plate is terminated here on a tag and is also terminated at the bridge at a textured metal stud, which is played by the bow. The nichrome wire is strung in place with the normal violin wire and forms a resistive circuit that can be measured from the sled. The bow has 2 functional units. There is a small box attached to the frog with a magnetometer and accelerometer whose outputs are added together, provide Euler angles that give us an orientation for the bow. It is strung with strings of nichrome wire which act as a resistive sensor so we can gauge our position along the bow. That is fed via a Molex connector to a wrist-mounted box, a rather large wrist-mounted box. This contains an Arduino Pro, a battery module, another Bluetooth 2 communications unit, and a constant current source for measuring resistance. The build process for the instrument was iterative. I started with the construction of the bow, which I've strung with 3 strands of nichrome wire terminated to Molex connectors with a wire wrap. These are capable of taking quite a good deal of tension and can tension the bow almost to the sort of tension you'd expect with a normal violin bow, which is essential for playing. The tension also pulls the nichrome strings taut, making them not perfectly straight, but straight enough to function. The bow can work on its own without the violin. It's a complete unit. The bow required a lot of debugging. The wrist box has gone through several iterations. As parts gradually arrived from overseas, deliveries of parts were greatly delayed by the current pandemic, which slowed down our development process. As parts gradually arrived, we were able to use our 3D printer to grow the box and change the box's shape to accommodate extra parts. Construction of the violin began with the design of the instrumentation sled, which is a phenolic board shaped to a piece of textured aluminium designed to conform to the side of the violin. The sled has gone through quite a few design changes and has outgrown its original dimensions, mostly due to the addition of the rechargeable battery pack. But is still able to fit inside the body of the violin without contacting the internal post under the bridge. It was important to me to keep the violin at least looking like a functional violin and behaving something like a functional violin. The final part of the design was the addition of the conductive plate on the neck, which allows the user to have an extra continuous controller that performs like a normal violin and looks like a normal violin. The technologies and control schema used for the body of the violin were first trialed in my Ambisonic Wonder controller, which I constructed last semester for Box Hill University. This uses a 50 centimeter soft pot as a linear controller. I considered using soft pots for the violin, but they marred the aesthetic of the violin and did not function like a violin string.
I wrote Cockwomble to chart the potential of the P-Bow. It's a text-based piece that uses sampling and pre-recorded audio. It engages with profane etymology for the purposes of lightheartedness and humor as a way of dealing with the current stresses of the world. The pre-recorded audio is kind of a fanciful dictionary/encyclopedia style reading and is interspersed by references to the wombles, and there's 4 binaurally spaced strings of insults underneath the main text. With the P-bow, I'm mostly concerned with just the bow and the potential of the violin body to switch samples. During the piece, samples of insults are played backwards and forwards along the violin strings at different times, and the violin performs the rhythmic role of the piece. I will show you a quick excerpt of it now. Please click the link if you would like to see the whole thing.
Cockwomble, noun. Cockwomble is a portmanteau of the words cock and womble. Cock is a slang for the male genitalia from the Middle English cock. Womble comes from the 1968 novel series by Elizabeth Beresford. Wombles are environmentally fastidious, furry creatures with pointy noses who reside on the Wimbledon Common in the United Kingdom. Cockwomble is often used as a playful and light-hearted derogatory term. The subjects of this insult are frequently individuals who have displayed some trait of buffoonery.
The aesthetic and practical design of the P-bow relies on the use of nichrome wire for both the stringing of the bow itself and for the replacement of the violin strings on the body of the instrument. Nichrome proved difficult to work with. Although it has a known resistance along its length that scales linearly, that resistance is low and cannot be measured with a normal Arduino without presenting substantial risk to the Arduino itself through pulling too much current through the divider circuit. To address this, I built constant current sources which are present in both the wrist controller boxes and the sled inside the body of the violin. These units provide 100 milliamps of known current, which we can use to sense small changes in resistance across the boards without presenting a risk to the Arduino's input. The first trials of the nichrome bow gave almost unusable input with huge leaps in the measured resistance. I found through experimentation that, against my intuition, rough surfaces, knurled surfaces and threaded surfaces actually gave better contact to the bow while it was moving and gave much more usable results. The current iteration of the wrist box and instrumentation sled are very bulky. This is due to the use of easily available off-the-shelf components and individual modules for the Bluetooth connectivity and the gyro. All of these functions can be replaced by this. We did order these for this project, but due to the current pandemic, they took months to arrive and were not available in time. The P-bow communicates to the computer via Bluetooth 2.0, which is then fed to Max MSP or Max-for-Live via the standard system serial ports. The assignments for these controllers is purely arbitrary, but we have currently assigned the bow position to scrubbing audio in a manner similar to Laurie Anderson's tape bow, and the neck controller string is assigned to the frequency center of a low-pass filter. Data input to the system must be smoothed before it is used. There are several cumulative factors adding latency to the performance of the instrument. The largest factor affecting the latency is the user-controllable smoothing function inside of Max that takes a median over a range of recorded values. Increasing the smoothing increases the latency.
As of June 2020, we have a working prototype design that has 2 pieces to demonstrate the potential of the P-bow. Those pieces are Cockwomble and Tubular. We also have a series of clearly defined refinements for future iterations and improvements of the instrument itself, as well as ideas and other complementary instruments for designing future works such as installation pieces, Ambisonic works and performances and compositions. Future background research will focus on the codification of instruments and the effect of using this existing language to undermine our expectations in art. We'll also be further developing other instruments for use in ambisonic environments, such as the ambisonic wand, the P-bow, and my data gloves, which are unnamed.
Thank you for listening to our talk, and please let me know if you have any questions.
Cockwomble. Cockwomble.